So, okay, quadratic functions. What's that mean? Okay, quadratic functions basically mean we're going to have equations that we're graphing that have x squared in them somewhere. Now, what you're going to see as we start to do this is there's going to be a lot of similarities with a couple of things we've seen before. This graph over here to the right is our parent graph. So where does it come from? Because before we were always looking at a chart or something to kind of tell us how this works. The best way I can think of to kind of see a little bit of where this parent graph is coming from is to go ahead and graph it. Ooh, somebody messed with my window. What? Wow, they really messed with my window. This is not fun. Okay. Let's try that again. And tone this down a little bit so some of you don't get a headache looking at it. All right. So we're just going to type in x squared. And again, the squared, let me move this up a little bit. It's just the square root button. We'll look at the picture first. Looks like the one that's on here. Okay. But when I pull up the chart, I want to chat a little bit about something. I want to find the center of my graph. And the center of my graph is the vertex. We've talked about that before. So there's a couple of things here, though, that I want to make note of. First, what I just said is that it's the center of our graph. But here might be the more important part of it. There is what's called symmetry around it. What does that mean? Okay. What symmetry is when you see the same thing on both sides of something. A reflection, you could kind of see something. You're seeing the same visual in your mirror. But here's how we're going to find our center, our vertex. Typically, on any parent function, my vertex is going to be at 0, 0. So what I'm going to do is I'm going to get 0, 0 here into the middle of my chart. And I want you to take a look at something here. So when I get 0, 0 to the middle, notice the y numbers above and below it. They're identical. Okay, they're symmetrical. 1, 1, 4, 4, 9, 9, 16, 16, 25, 25. That's always going to be true once you've found the center, once you've found the vertex. And so what I basically tell people is when we're looking at a parent graph, yes, I can get a chart going again. If that was working for me before with charts and shifts. 0, 0 would be my vertex. And then I'm just going to get a couple of x values to the left and to the right. So I just use 1 and 2 and -1 and -2. They're the closest ones. And if I do 1 squared, I get 1. Same with -1. If I get 2 squared, I get 4. And same with y. And those are the points 0, 0, -1, 1, 1, 1, -2, 4, 2, 4 that create this parabola, okay, this x squared function that we have. So whenever I talk about a parent graph, these are the points that I'm referencing that we're going to be starting with. So you're going to notice as we go through here, I'm going to avoid or ignore some of the things that are on here. Like here, they tried to make the chart here, but they kind of forgot something important. And that would be the vertex that's in the middle. How you forget the vertex in the middle of a chart, I really don't know. But there's one more piece to these graphs that we haven't talked about that I want to make sure we do. That's called the Axis of Symmetry. Sounds like a real tough thing to figure out, but it's not really. Because the Axis of Symmetry is kind of what it sounds like. It's the line, the axis, that shows us where the reflection is. And it always goes through the vertex. So once I know where my vertex is, if I wanted to draw the axis in, and sometimes we will, I can draw that in. So if you think back maybe towards grade school, you used to have some projects probably where you'd have a picture, and they'd have a folded line, and if you'd fold your paper on the folded line and open it back up, you'd see the same thing on both sides. You'd see symmetry. Same thing goes with here. That's where the name comes from. Now, there's a couple of forms these are going to take that we're going to have to get used to as well. But here's where the similarities start to come in. Okay, the vertex form of a quadratic. Now, I swear I've seen something like that before somewhere else with what we've been doing. H and K and, yeah, no, let's see here. Oh, yeah. Graphing radicals. Graphing absolute value functions, okay? The order of everything is still the same. The only difference now is we got parentheses and a squared in there instead. But if we went looking sometime for transformations, for shifts, they're the same as they've always been. Inside the parentheses is still my left and right, the opposite of H, the opposite of what I would think. My K value is still my up and down. Hasn't changed. So once I know those, that's going to give me an opportunity like it did before with our square roots, where I can graph the parent graph and then shift if I want to. It's an option I have. But just one more reminder here again, that our parent graph's vertex is always going to be at 0, 0. So when we're doing this, we can do shifts, we can do charts. So here's what we're going to do. Here's where I'm going to go way off what this particular note sheet wants me to do. We are going to ignore all of this craziness because we can make connections to what we've already done. So here's my options. If I want to go with a parent graph and then shift, okay, I'm going to do that first, then I'm going to do the graphing calculator, and they both work the same. So if I do my parent, I look back up there at the top, and I'm like, okay, so 0, 0, just little dots. 1, 1, negative 1, 1, 2, 4, negative 2, 4. Okay, I'm not connecting those because I noticed this time there are shifts. So if I need to peek at my directions up above as I'm doing it, that's okay. I don't have to be an expert the first time I do it. And so I notice my plus 3 is the opposite of what I would think moving here. Well, that would be to the left. So left 3. And then the plus 2 on the end is my up-down shift, but it is what I would think, which is up 2. So what's that mean to me? Well, it means I'm going to take each of these 5 points, and I'm going to move them left 3 and up 2. Left 3, 2, 2. Make sure I do them all. 2, 3, 2. And that would be my graph. And if I was asked to label my vertex and my axis of symmetry, I can do that. Here's my center point of my graph. It's at negative 3, positive 2. And I might draw your reference to something here. Yeah. Oh, when we were doing like, let me come back here. Yep. So my initial points are the new ones. My parent points are the new ones. Maybe that's the way I need to put it. Okay. So when I was doing these, since my quadratic parent point is x squared, y is really just taking the x values and squaring them. Okay. So 2 squared is 4, 1 squared is 1, and so on with those. So that's where those first 5 points, when I'm doing the parent graph, are coming from. And so once we shifted them, Notice my vertex left 3, my vertex went to -3. Up 2, my vertex went to 2. There's a direct connection between my shifts and my vertex moving. So if I'm ever confused on that, that's something I can come back to. Now, if you're like, okay, I still don't like this whole parent point and shift thing. Not my thing. Not a problem. Because we still, between our calculator in here and the apps that I've shared with you before, have the option of getting myself a graphing calculator, or a y=, typing in, let me move this back over so we can see it later if we need to. So x plus 3 squared plus 2. And at this point, I would just hit second and graph, and I'd get my chart up. Now, here's the one thing you do have to do one way or the other. You've got to be able to figure out where your vertex is. And so like we just mentioned here, knowing left and up, left affects my x values, up affects my y. So if I was trying to figure out the vertex that way, I'm like, well, left 3 is negative, up 2 is positive. And the reason I want this is so I can, when I know with my chart, I want that -3, 2 in the middle so I can see the symmetry. So when I get it here, I see the same numbers above and below it. Because now when I go to graph it, I'm like, okay, so -3, 2, there's my first point. And then I've got -4, 3 and -2, 3. And then I've got -1, 6 and -5, 6. There's my 5 points. I connect the dots. I let the chart do all my work. And that's fine. Doesn't matter. Okay? As long as I can get to my answer, that's what's going to be important. Get my graph, I can label my pieces. If I want to put the axis of symmetry in, wherever that center point is, my axis of symmetry is at x equals -3. It's just the x value of my vertex. But I've got to put the x equals. I can't just put axis equals 3, because that's just a number. That's not a vertical line. So, I mean, there are some detailed things I've got to watch out for. But for the most part, this is just kind of repetition of some stuff that we've already done, which hopefully is going to help us start to make some connections here. Okay. So as we flip over, we're going to stick to the graphing part. And again, we're going to do our own thing. So depending on how I want to do this, again, I have options. But I notice this time when I go to graph, there's a number in front. There's an a value. It's 2. So how do I deal with that if I'm doing a parent graph? We're going to deal with it exactly the same way we did with the radicals. I'm still going to have my parent points. Those are not going to change. But just like when we did this with radicals, if there's a number in front of the parentheses, if there's an a value, we're going to make one more column. And we're going to multiply our y values by that number. Whether it's a positive, negative, fraction, doesn't matter. So 2 times 4 is 8. 1 times 2 is 2. 0 times 2 is 0. And work my way through. These, for this particular graph, because I have an a value, are now my parent points. Again, sometimes we're going to stretch off. That happens. -2, 8, kind of high here, but that's okay. Let me give myself a little extension here. -1, 2, 0, 0, 1, 2, 2, 8. But that's not my final graph, of course. Because I notice I still have transformations. I still have shifts. So the negative inside's the opposite of what I would think. So we're going right 1. And then the -2 on the outside is my up, down, and we follow with what the sign says. So right 1 and down 2 is what I'm going to do for all of these. So right 1 and down 2, 1 and down 2, down 2, right 1 and down 2, right 1 and down 2. And the cool thing is, if I do it this way, a couple of things I'm going to see this way. First, when I go to find my vertex now, which is here, at 1, negative 2, now I can look to see, yep, my shifts were right. Right 1, down 2. So that makes sense. And then my axis of symmetry, whatever the x value of my vertex is. X equals 1. And as I've said before, and will continue to say again and again and again and again and again and again and again, if parent graphs and shifts are not your thing, you are absolutely, positively okay to just type it into the calculator in the y equals. If I want to take a look at it first, I could. So I'm like, okay, it should be moving right and down. It did. Pull my chart. Again, if I know my vertex, it's going to make it easier. Otherwise, I can scroll up and down the chart, I guess, to see. But if I know where that vertex should be, and I work on getting that to the middle, so there's my 1, negative 2, 0, 0, and 2, 0. Negative 1, 6, and 3, 6. I've got the same 5 points. So the graphing shouldn't be an issue. We just got to give it a little bit of practice. So speaking of practice, who needs practice? Well, we need practice. So I want to show you a couple of them on the back that throw a couple of twists in. Want to make sure we've covered those. And then I'm going to kind of give you some time to work with some things here. So if we flip over, all right, so we're going to graph. We're going to find the vertex. We're going to find the axis of symmetry. Okay, I'm going to start at number 3. Because one thing we haven't seen yet is a negative a value. Okay, it's like having a negative 1 over here. So let's do it the opposite way this time. Let's go to the calculator. So if I'm going to go to the calculator right away, first question, and I kind of would like to know this before I punch it in. What's my vertex? Negative 2, 1. Excellent. So we get this typed in. So I'm going to look at my graph first because we'll see if it makes sense. So it looks like it went left and up. Left and up. Okay, that makes sense. Pull my chart. There's my negative 2, 1. All right, let's get that towards the middle here. So if I know this is at negative 2, 1, then what else have I got? I got negative 1, 0, and negative 3, 0. I got negative 4, negative 3, and 0, negative 3. And when I use the chart, I just draw it in. Now it does ask me for the axis of symmetry as well. So I'd go ahead and we'd get that in at negative 2. Now if you're a charter, okay, if you're going to work this out, get your parent graph working and all that, we're going to have one other step that we're going to put in. My parent points, again, do not change. And once I get used to them, I pretty much can work that any way I'd like to. I have an a value this time, though. It's negative 1. So I'm going to multiply all my y's by negative 1. Which basically is just going to change the sign on all of my y values. Now, it's a little trickier since I graphed the other one first this time. Maybe I shouldn't do that in the future. We'll see. So I'm like -2, -4. I'm just going to put in some little tiny dots here with my color. -1, -1, 0, 0, 1, -1, 2, -4. But here's what I want you to see. I look to see where my shifts are at. Left 2, up 1. So if I start from my pink points, and I go left 2 and up 1, oh, it runs into one of those. Left 2 and up 1. Left 2 and up 1. Left 2 and up 1. Did I go, oops, pink was supposed to be over here. Left 2 and up 1, okay? I get the same points. So no matter how we do it, it's really not going to do anything to change my graph, but I just need to be able to figure out those two things on my own. So the last one that I thought could cause a problem, because we won't be doing decimally stuff, so those of you looking down saying he's going to do the decimal, I am not going to do the decimal, I'm going to do the fraction. If you go calculator on this, go calculator right away. If you go chart, here's how we're going to handle this so we don't worry about it, so we don't freak out. Same base numbers. I got another extension here. Ooh, -1/2. Ugh. Okay, well, let's see here. Half of 4 is 2, and then I got a negative. Half of 1 is a half, but it's negative. Half of 0 is still 0. -1/2, -2. So don't let the fraction stuff, mess with you, make you think you can't do it. You can. So now I've got my -2, -2, -1. You're like, how do I deal with a half? Just go between 0 and 1. Get yourself kind of close here. 0, 0. 1, -1/2. 2, -2. But these are the ones, if I go at parent points, where I'm going to graph these guys. So we're looking at left 4 and down 2. 1, 2, 3, 4, 1, 2. 1, 2, oops. 1, 2, 3, 4, 1, 2. Still want to stay between lines. 4, 1, 2. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. I get my graph in. I label my vertex either by looking at my shifts or looking at my graph at this point. And my axis, ran myself out of room, is at -4. Now, if you didn't notice at the start when we first started doing the notes, the assignment is on the front of the note sheet. But I've made an adjustment to it. I'm purposely trying to delay here for a minute in case some of you are still writing. I don't want to go flip into the other side on you to show you that. But basically, on the front, the last 3 problems are being crossed off. I'm trying to keep life simple today. And I'm like, we got 5 of them, we can get through 5 of them. Here, I'll do this. If I need to flip back in a moment, I will, just to make sure I'm clear on what we're up to here. So 40, 41, 47. Okay. The book is open up front. I have 2 books open if we take them off on top of one another. And that's what the graph paper that you were given for is, where you can do it, your chart, just calculator, doesn't matter. Okay. Keys up front, just make sure that you're labeling your vertex, labeling your axis of symmetry and that type of stuff. And then tomorrow we'll just kind of continue in this area.